Algebra 2. I'm Miss Tate, and I will be making your pre-recorded videos for this week. A couple of tips as you're going through your videos. Write down what we talk about. Research has shown that you remember and learn more when you write things down. So don't just watch the video. Take some notes. Blank notes will be posted on Canvas as well. The second tip would be if I say to pause the video, pause it, and then work through the problem that I instruct you to. Then you can start the video to make sure you have gotten it correct. So that's the way to get the most out of the recorded video. Started on our notes, you might want to pull out your homework from last night because you're going to see a lot of similar problems, actually some of the exact same problems, to lead you to some patterns. So the first thing you see on your notes is the definition of a parent function. And so a parent function is the simplest function of a family of functions that preserves the definition or shape of the entire family. And so what do I mean by that? Well, look at the front page of your homework, which is also the front page that you will see in the notes. All of these functions have the same shape. And the first function that you see here, f of x equals square root of x, that's the parent function. It is the simplest function in the family of f of x. You also see some function notation here. Remember, f of x is the same as saying y. And so if you look at your first problem here, it says f of x minus 5. So notice that every time you see an x minus 5 was plugged in its place in this equation. In this equation, x minus 3 was plugged into the place of x. In this function, x minus 1 was plugged into place of x. So just some notation, and we'll continue working that as we go. So let's look at this first problem. It says, what do you notice about the shape of each of these functions when you compare it to the parent function? And you're taking each graph and always going back to the parent function at top. And so what you should have said is that the shapes stayed the same. But what happened is that they were just shifted or moved right. Now, we can go back and talk about how many units these were moved right. So again, you're always comparing to the parent function. So we notice that the parent function goes through the origin. It goes through the point 0, 0. And if we look to be moving right, we can see that this first example has moved right 5. That's called a transformation. Our second example has been moved right, always comparing to the parent, 3. Again, comparing to the parent function, we see that this is moved right 1. And then we can see it's been moved right 4. So if I think about what values on this have changed, it's the x values that changed. So the x value that was at 0, move this down a little bit, the x value that was at 0, that x value is now 5. The x value of 0 now became 1. So it's the x values that had changed. And so for all of these, we're going to say describe the transformation. Well, we've really done that. It's right so many units. All right, go ahead and turn the page and we'll look at this next set. That was also on your homework. So once again, we see our parent function at the top of the page. This is our parent function. It's the most simple function of the quadratic families of x squared. So our first function, we've taken f of x plus 2, which means plug x plus 2 in every time you see an x. What would you say? How has this changed? How have they all changed? So I'll give you a moment. Make your conclusion. You should have said that they all have the same shape, but they are moving left. So we can go back and talk about how much. We can see that this looks like it's moved left 2. Introduce some vocabulary, remind you of some vocabulary. This quadratic has a vertex at 0, 0. It's been moved left 2. Here our vertex and the whole function actually has been moved left 6. In our next example, that point 0, 0, and the entire function has been moved left 4. And our last example has been moved left 1. So all of these, the same shape, they've been moved left. The x values have changed. And so when I describe the transformation, I'm going to say left so many units like we did above. All right, so let's look at this next page. Once again, we have another parent function. This is an exponential. You looked at those some in Algebra 1. And so as you're looking at these together, how have they changed when you compare them to the parent function? What do you notice? And what you should notice is that they're the same shape, but they've moved down. So let's go back and look at how many units they look like they've been moved. So if I look at this parent function, I can see maybe 0, 1. Looks like it's now 0, negative 2. So how many units has that been moved down? We would say down 3. Let's look at this function notation here. Notice it says take the same function, but then subtract 3 from it. That's where this equation has come from. Okay, what about the next example? What did you say on it? You should have said down 6. Okay, on the next one, let's look at function notation. Notice it's the same function as our parent, 2 to the x, but we're subtracting 4 from it. And if you look at the graph, we can see that that's gone down 4. And our last example would be down 8. So the shape has been preserved. What's different is that they've moved down so many units. And if you're moving things up and down, what values have changed? Well, take this point 0, 1, for example. If I take 0, 1 and I move it down, the x value is still 0, but the y value went from 1 to negative 3. So the y value is what has changed. And if you were to describe that transformation, you would say down so many units. That box just means you're going to write 3 or 6 or 4 or whatever there. All right, last page on our homework. So once again, a parent function. Here we're looking at the parent function x cubed. So when we start comparing, how have the 4 of these graphs changed when we compare it to x cubed? We should have said they've all shifted up. So, take a look. This once again goes through 0, 0. That point has become 0, 5. Up 5. Notice the function notation. I'm taking the function f of x and adding 5. F of x is x cubed, and I'm adding 5, up 5. Then we've got up 2, up 1, up 7 units. And so at the bottom, this is the same shape, it's just moved up. And moving up changes the y values. So if you were asked to describe that transformation, you would simply say up so many units. Okay, so now kind of the new stuff, and we're really putting all of this together. So we have this crazy looking parent function. And I went through and I've labeled the 4 points that you see here because we're going to move those according to what it shows me here. What I would suggest you do right now is go to problem 4, pause the video, see if you can determine what this notation means. Okay, so now that you've had a chance to pause the video and look at that, you could go back and look at your notes and see what does f of x minus 1 mean. And I'm going to pull out page 1's notes. F of x minus 5. F of x minus 1, oh, there's the exact same thing. So what did those do? Those moved the function right 1. And that's a change in our x value. So this changes your x. What does this plus 3 outside the function do? Do you remember? That changed the y values. So in this, actually both x and y are changed. So how are your y's changing? Up 3. So let's actually translate that. I'm going to go point by point. So take a look at your parent function. It contains a point -4, -4. And I'm actually just going to take my pencil and move this point right 1, up 3. And so it becomes -3, -1. That's the new point that comes from the parent function. Let's take 2, 0. I'm actually just going to take my point, my pencil, and move it right 1, up 3. So that becomes the point 3, 3. Let's take 4, 4. Move right 1, up 3. 1, 2, 3. And that point becomes 5, 7. Take 6, -1, and move it right 1, up 3. 1, 2, 3. And that becomes 6. Whoops, I was looking at the old one. That becomes 7, 2. And there's my new function. Notice, compare it. The shape stayed the same. It does look like it's been moved right and then up. That's a good way to check yourself. Now, I would pause the video and I would work on the next two problems. And then once you finish, start it back up and see if you've gotten them correct or not. So go ahead and pause it now. So once you've had a chance to pause the video, let's see what you've taken care of here. So f of x plus 5, that changes your x, and you should describe that as left 5. And then what does this -2 outside the function change? It changes your y's, and it changes by going down 2. Now again, you're just going to go back to your parent function and take each one and perform those transformations. So -4, -4 is on your parent function. Go left 5, 1, 2, 3, 4, 5, and down 2, 1, 2. Take 2, 0, left 5, 1, 2, 3, 4, 5, and down 2. -3, -2. Take 4, 4, left 5, 1, 2, 3, 4, 5, and down 2. So -1, 2. And 6, -1 on your parent function. Go left 5, 1, 2, 3, 4, 5, and down 2, 1, 2. One of the things that you need to make sure that you're doing each and every single time you do a transformation, you need to write the transformation down. So you won't believe how many people write left 5 and then they go graph it and do right 5. At least I knew that you knew to go left, and maybe you just got your right and left mixed up. So be sure you're writing those down. So last problem, you should say x changes by the x plus 2. This changes our y, so we're going left 2 and down 1. So again, take your parent function, -4, -4, go left 2, 1, 2, down 1. Take your parent function, left 2, down 1. Okay, take 4, 4 from your parent function. Left 2, 1, 2, down 1. And take 6, -1, go left 2, down 1. Okay, let's check it really quickly. Did the shape change? Nope, the shape is the same shape as the parent function. Does it look like we went left and down? And yes, it does. And I would go back really quickly and write these ordered pairs down that these have become. That makes it really easy for your teacher to check your work as well. And that's the end of this video. Thanks.